Good afternoon, everybody. So we'll start our talk, and we're going to talk to you about interactive analytics and how we do it at Criteo. So my name is Julien, and this is Gregory. We're both software developers at Criteo in the Paris office. And a few words about Criteo just to explain you what kind of challenge that we have. So Criteo is a company that does performance advertising. So you probably never heard of us, but we're actually the second biggest ad network in the world. And the first one is Google. We have we can reach 1 billion persons, so that's quite a lot. We serve 2 billion ads a day. And we can handle up to 500,000 HTTP requests per second. That's spike. And we also happen to be sponsoring this conference. Why do we do that? Because we are getting bigger, bigger, and bigger. And so it's good for us to get to know the other people. And also because we've got a nice HR team that is actually interested in getting to know you. So feel free to contact any of us. And we also have one of these nice person here at the front row. She's hiding, but she's there. Hello, Ola. So feel free to come if you're interested in the kind of things that we try to solve. So, as I told you, we are quite big. We've got a lot of HTTP requests going. And we've got a lot of data. We've got a 10 petabyte Hadoop cluster. The problem is that data are not in sites. So it's good to have all that data, but we need to be able to extract information and to be able to show our users what's going on for real. So my team is specialized in building analytics for our advertisers. So advertiser would be your client. So for example, that would be an e-commerce website that would like us to show advertising about his products. And what we want to be able to do is to do interactive analytics. So we don't want to show our users, our clients, reports that are just generating during the night. What we want to do is offer them a way to be able to drill down, to slice and dice, and to look at the data in the way that makes sense for them. The problem is that, obviously, they want to do that very quickly, so they want to have sub-second latency access to that huge data set that we have. So, easy, right? We all wrote a website to do reporting in the past. That shouldn't be that big a problem. Well, the problem actually is that at our scale, SQL doesn't work at all. The size of the database would be so huge that it's just not scalable with the current technology stack that we have access to. I don't know if you tried to scale SQL, but it's not that great. We did try it. So we ended up adding a lot of caching layers to just make the query fast. We tried sharding, we tried denormalization, and we ended up with a schema that was just a nightmare to maintain. And in the end, it didn't work properly. We had latencies of up to 30 seconds to answer basic queries like give me the number of person that clicked on an iPad. So that's not good enough. And obviously, doing all that gets complicated very quickly. So that was not a good solution. Another path you could be trying, actually, is NoSQL. So, for example, ideas that we heard about is storing everything in Cassandra or HBase and do a huge amount of pre-computation so that the data is accessible and you can access it in a very quick manner. The problem is that pre-computing actually is not that very practical. Why? Because when you've got 10 dimensions on the table, and when you won't be able to filter by any kind of dimensions, pre-computing the data set is both very complicated because it's going to be huge, and by huge I mean probably need hundreds or thousands of nodes to just store the thing. The other problem is that it's going to take days to actually pre-compute one day of data. So that doesn't scale either. So we went to look for any other alternative solution, and we actually found one that we thought at the time was probably matching our needs. And this technology is called Druid. So Druid is a columnar data store. There are a few of them available out there. For example, Vertica is one that is usually used in that kind of space. It loads data in memory, but not only, which is very interesting for us because, for example, our advertiser most of the time are interested in what happened like a week before. They want the ability to drill down and look at the data that was there like a year ago, but actually it's not the majority of requests that we serve. So being able to load the data set into memory is actually a huge speed booster. And it's distributed, so we can have as many number of nodes that we want. Obviously, it's highly available, which is absolutely required because you're talking about building a website on top of it that looks like a bit like Google Analytics before on it, so it needs to be accessible. Data can be replicated, so losing a node is not an issue. And something else that is definitely not that common in that space is that it's also real-time. So by real-time, I mean that we're capable of ingesting events in real-time, doing a tiny level of pre-computation. So we try to aggregate the data by hours, for example, and then it can be stored into the cluster. Lots of technology, especially the columnar data store, are not usually that much optimized for that kind of use case. And best, it's open source. So you can see by yourself what it does under the hood. You can commit, and you're not stuck with a third-party vendor that might continue or not this technology in the next few years. So you can do whatever you want with it. So we'll dig into the semantics.
Hi, everyone. So let's talk a bit about semantics. Some of you may be familiar with databases, some maybe not. I was not just a few months ago. But what all of you probably know is every time you have a new technology that comes out, it comes with its new words, its own vocabulary. Sometimes they just invent new words for old stuff, so it just sounds complicated. But if you don't get the words right, you probably don't get the IDs right. And it's also a good point to start to introduce some of the architecture points. So let's take a quick tour around most important notions. In databases, usually you have two levels of access to your data. You have the database itself, and you have tables. In Druid, you just have one, which is the data source. And there's a reason for that. It's because your data is a bit more isolated than in common data sources. We will talk about it a bit later, but you cannot make join on your data with Druid. I'll explain a bit more. Segments, it's an important piece of Druid. Basically, the segment is your atomic chunk of data. This is the level where replication will occur. This is the level where load balancing will occur. And this is the atomic object that Druid will manage in the cluster all the time. What a segment is, it's an aggregation of data around time. And time is a very important point. So basically, you all know what a timestamp is. If you have a data model with no time, and if your data is not timed, you don't want to use Druid. It's usually every time your timestamp is the primary key of your data model. And how this data is managed in a segment? Well, basically, your data is rolled up around time and around other dimension in your segment. So you can consider a segment like all your data aggregated around your dimensions in one piece of time. So I don't know who is familiar with dimension, metrics, and common language of databases, but basically you can consider the dimensions are the parameters you will filter on. For instance, we want in our business to know the number of clicks for one client. Well, the client will be your dimension, and the clicks will be your metrics. So the metrics are the values you want to compute. And basically, the process of creating a segment, it's sharding your data around your dimension, which is actually ingestion. We will not detail ingestion. Julien just said quickly that it occurs in real time. There is a lot to say about ingestion with Druid. If you want more details about this, just come and talk to us after. We don't have enough time to cover all the aspects. Maybe. No matter. Let's take a look at what a query looks like. So this is a common query. Yeah, it's easier. Working? Is it working? Yeah? So this is a common query. Basically, you have your query type. So here it's a time series. I will explain a bit more what kind of queries you can have after. Your data source, so I explain what it is. Obviously, you want to ask one thing in this particular data source. The granularity, as I said, all your data is timed, so you basically want to ask maybe all the values on one time interval. You can see at the end the time frame you will interrogate. But you can ask this data, for example, for every day or for every week. So the granularity is the level of aggregation you want around time. You can consider it as a group by time, actually. And you can specify here any kind of interval you want. But, of course, intervals which are bigger than the granularity of your segments. Meaning, if you sharded your segment for daily aggregation, you cannot ask hourly granularity here, for instance. Other kind of aggregation, so these are the metrics that you will want to ask details about. So you can find very basic standard type of aggregations in databases, obviously sums, row counts. Hyperunique is an interesting one, actually, and we will detail this one a bit more later, because in our job, for instance, what we want to do is to display performance of our clients. Displaying the number of clicks that we generated for a client is very interesting, but it's not the real value. For instance, if you have one frenetic guy who will click 100 times on your ads, it doesn't make much sense. So one thing which is more interesting is to know the number of unique people you touched. And to do this, you need to compute unique count of users. Unique count of users is a difficult thing to compute. So hyperunique is a kind of approximate, super fast method to compute this. We will detail a bit later about hyperunique. Filtering, obviously, this is the dimension you want to filter around. So here, you're filtering for one specific client. Of course, you can filter about categories, device, any kind of stuff you can think about. Selector is a kind of equality operator, but you can also choose regular expression in Java, or actually here you can implement just any JavaScript function on your own, and the performance are the same. So it's working pretty good. Intervals, I already told about this one. This is one example of query, so it's time series. It's a very common stuff you want to do with Druid. In this case, you want to extract one particular metrics. So revenue generated is the amount of sales that we generated for one of our clients over a month, and this is a granularity of 1 day. So basically, we extract every value for every day. This is very common. Group by in top N, this is also very common stuff in databases. So it's the same kind of query, but this time you want to extract these values for each specific device, for instance, or for every kind of categories. If it's devices, it's not a big problem because you will have just 5, 6, 7 different devices. If it's categories of products for the clients, we have many, many of them. So it can be not very interesting to have a group by for all of them, but just the top 10 of them. And actually, it's a problem which is very common in advertising. So Druid is quite optimized to extract just the top N categories. Well, not categories, but any dimension, of course. The thing which is interesting to note is it's an approximate method. It's not just a group by and extraction of the values. So you have something which looks like this. And not much more. And this is important to note. With Druid, you're actually making a trade-off, and you have to understand the trade-off. The point is, you want to do this, what we explained yet, very fast, and it does it. But it does not much more. So you cannot expect to have the full features that you have in common databases. You will not make joins, as I said. Your data model is more isolated. You will do this very, very fast, but you will not do other stuff with it. So there are a couple of other queries you can see on the Druid website for information about this, or you can come and talk to us so we can tell you about this, but you will not do much more.
So let's look at the high-level architecture of Druid. We won't go into details, but basically the important parts are there on that slide. So we start by ingesting data in real time, and there is a node that is actually responsible for that kind of things. So as I said, you can have several instances of it to do failover and sharding. Once the data is ingested by this node, when a segment is terminated, so for example when the time period ends, or if the segment size limit is reached, the data will actually be copied to the historical nodes. And the historical nodes are the one that will actually store the huge amount of data that you want. Something that is interesting to note is that this node actually only store a copy of the data. So it's not written there on that slide, but the data is actually stored in what we call cold storage. So for example, we're using HDFS, but you could be also using Cassandra for storing the data. And Druid will just load it on startup and be able to serve requests from there. After that, you've got the broken nodes that are actually the nodes that will receive the queries, for example, from your website. And it will split the queries between the real-time nodes and the historical nodes, depending of the time range that you're requesting. So for example, if you want to have data for the last hours, it will hit the real-time nodes. If you want to get data for the last year or so, it will probably hit the historical nodes and maybe one real-time node if he has the data for the last hour. One thing that is interesting to note is that every node has exactly the same API. So basically, one thing that you could do as a developer is hit any one kind of that node, any kind of node, to just try to understand where your data is located. So for those of you that have heard that term before, it's actually Lambda architecture, so it's exactly the same. We won't talk about ingestion, but we do, Druid is able of reprocessing the data on daily basis or any time period that you want to reload it on the historical node.
Now let's take a look at how this works, actually. We told you that Druid was a column-based database. You may not know what it means, but it's very interesting to take a quick minute to explain this. So this is what data looks like. You have your timestamp. I explained why it was important. You have your dimensions, so some pages viewed, language, country, etc. And you have your metrics, something you want to aggregate. This is data. And this is how I look like before breakfast. Column-based means actually you will never store a row altogether. You will store just columns. And this has a couple of advantages. First one, it's more CPU and memory efficient, because basically you will not parse all the data. If you want to extract some metrics, filters just by pages, and you want to extract added values, you will not have to parse city, country, and deleted metrics around. You just parse what you need to. So it's more efficient. But it's not the only point. When you store it this way, you can make a couple of optimization on top of it. A common thing when you have string values is to create a dictionary. So you make dictionary encoding, and you will not store the values themselves, of course, but you will just store corresponding IDs of these values. So you have an example of what you can do here. You create ID for each string, and then you store them. And when you store them this way, you have arrays of homogeneous data. And arrays of homogeneous data is something that you can compress very well. So it's very optimized compared to storing rows just because of this. Once you've done this, you can do something better. Basically, you have to understand that the performance for Druid comes from two things. The first one is, well, basically, when you make a query, you make two things. You need to access your data, which means finding in which rows you have values which match your filters, and then you aggregate them. Aggregation, obviously, is something which is linear complexity. So your performance issue can come from accessing your data. And accessing your data means knowing in which rows you have values that match your filters. If you store it, just like Iron Maiden in 0, 1, 2, it's interesting, it works, but most of the time you will not have just one filter. You will have a couple of filters. If it's all filters, it's easy also. You just add values. If it's n filters, and if you have hundreds of dimensions, and you have billions of rows, like we do, it can get complicated when you make end operation, actually. You have to parse a lot, and it takes time. So you make a change here, which is, instead of storing values like 0 in 2, 0 on 2, you will store a binary array in which for every row in your database, you indicate if your value is present or not. And this is something you can play with to make binary very efficient operation. So basically, you store just this way, and you can compute OR and AND operation very efficiently to access your data. Another thing interesting is all the sketching algorithms which comes with Druid. I talked about the top-end stuff, and I introduced hyperunique. I won't detail a lot, because we don't have much time. So once again, if you want more details, just come by after and talk to us. But just a quick word. If you want to compute a unique count on 2 billion rows like we have, you will have to store every user ID. We have 2 billion ads a day. We have about the same amount of events from advertiser site. So you can do the math. Just to store user IDs, it would take approximately 100 gigabytes of data every day just for that. And you can also imagine how much time it takes for one query to compute the unique count on this data. What hyperloglog does is it doesn't store the data itself. It stores a sketch of the data, which allows Druid to compute in constant time, so it's very efficient, an approximate unique user count. The trade-off, of course, is a small loss of accuracy, so you can lose up to 3% of accuracy, but you have constant time,
And you have extreme storage reduction. This data would take 100 gigabytes a day. It just takes 100 kilos. So how does it perform? We have tested Druid on a small cluster. It's a pre-production cluster. We have injected what represents 3 months of data for us. It's 1 billion aggregated row. The aggregation comes from about, I don't remember exactly the figures, but it should be about 400 billion unaggregated rows. It's daily aggregation. We have 4 historical nodes, so a couple of cores. And this is what we are trying to do looks like. This is the homepage of the website where we display performances for the advertisers. And you can see on this page that we have a couple of queries. So on the top, you have about 10 possible time series queries. You have group by queries under it. And our goal, as you remember, was to display this in quite real time. It's web browsing, you know, so if it's too long, people will not like it. And it does the job, actually. This homepage, we can display it running every query under a second and with no cache. We didn't talk about the cache, but Druid also, of course, implement a cache. Without cache, we can do it under a second. The cluster can run more than 200 queries a second. And on top of that, the good news is it's completely CPU bound on its historical nodes, which means basically you want to go faster, you just add nodes, you add replications, and you can go even faster. So it's fully scalable. You just need to adapt the number of historical nodes depending on your amount of data. And basically, it works.
So to conclude this talk, our experience is that Druid is very, very good at interactive analytics because it's so quick at doing it. It's also a very nice open source product because we had a very nice developer experience. We didn't have that many surprises. Generally speaking, when you try new tech, you might have a few problems. Here, generally speaking, it does work and it does what is advertised. And there is not that many people using it, but the people that are actually using it are quite involved in the community. So it's very easy to get some answers on the IRC channel of the dev team. There is also a Google group, and it's very nice. We actually met the guy and told them, and they told us that if we wanted any kind of help to tune the cluster, they could make a call with us. So that's very nice from them. However, Druid is not a silver bullet. As we said, it's very targeted for one use case. It's not like your SQL database replacement at all. Something that we learned is that you do have to understand the internals. If you don't know how Druid is storing the data, how Druid is building its indexes, you will have some bad performances out of the box, so that's very important. And obviously, the data model matters a lot. You have to choose your dimension so that it makes sense, so that Druid can actually build indexes that are compressed a lot. If you don't do that, well, again, the performance would probably be not that good. But generally speaking, we've been very happy with the technology. It works great, and we've been able to build a website that is actually solving real problems for advertisers, and that's great. So thank you. I think we are over for the talk, but if some people want to ask us questions afterwards, we're happy to answer them.
We have no time for questions now?
It reminds me of good old array programming and K and this stuff. Am I right here that it's like array programming languages?
personally, I'm not familiar with array programming, so I'm not sure what you mean, so I cannot answer that question.
I'm not sure neither, but I think the point is the level of the amount of data we are dealing with. Actually, we didn't go very deep into details, but the organization of segments, the way the data is rolled up, putting everything in memory, there was no technology who could deal with that amount of data yet. They didn't actually invent anything new. They just took the pieces of architecture that existed to solve a couple of problems and to match that specific problem with big data. Actually, it's a lot of people talk about big data. In our case and in their cases, it was true. It's just the good match to answer this problem, I think.
Hi, I would like to closer. Okay. I would like to ask you, did you consider using InfluxDB, for example, instead of Druid?
So we did try a few technology. We know about InfluxDB. We also know about like what is it called, OpenTSDB. There are quite a few technology that are actually quite good at storing time series in general. We didn't try InfluxDB, but we look into OpenTSDB, and OpenTSDB is not that good at filtering by multiple dimensions. Actually, it's an interesting question, because in the end, if you try to do what we did, you can spend like the next 2 years just trying the hundreds of technologies that might solve the problem. We didn't have that time, so we definitely didn't try everything. The way we worked is that basically we try to think about the best way that we would do it and find any kind of technology that would actually match that architecture. And we quickly found out that Druid was probably one of our best bets, especially because it's already used quite a lot in the ad tech space. So we have exactly the same problem that the person that are actually developing that technology.
On top of that, I don't know neither very well, so I cannot answer specifically for this one. But we had in-house other solutions which allows you to store projection of your data. Actually, it's the way many people works. You store a couple of projections and then you join them to filter. Vertica, this is what we're doing with Vertica. And you have very good performances for that level of data, but it's 30 seconds still. 30 seconds, you cannot do it on web browsing. It's not possible at all. So on us, for all what we tested, Druid was the only one who did it. And it seems like big players, when testing, found the same thing. We didn't talk a lot about the community, but just a few words. Druid is actually used by Yahoo, eBay, Netflix, and every time for that kind of problems. So there's an ongoing consensus on it's probably the technology that match this particular problem today.
So, do you know how old is the project?
Excuse me?
How old is the project?
Druid itself?
Yes.
It was open sourced 2 years ago, I think. It's a bit older, of course, but it's quite new. It's still version 0.6, so it's still quite new.
Thanks.
Hello, it's your only data store, or you have something, you know, like, I don't know, like Redis or something like that for in-time, real-time storing?
So no, Druid is not our only data store. We are only using Druid for our reporting, basically. Behind that, we are storing everything into Hadoop. So as I said, we've got like a 10 petabyte Hadoop cluster where we're storing all the raw data. In Druid, we're storing pre-aggregated data by specific time periods. In our case, it's hour or day. And we do have also other technologies to do more complicated reporting, where the performance doesn't matter that much. Especially sometimes we want to be able to do joins to be able to build complex report that were not at least initially planned in the development. So Druid, for example, is not good at that because you have to have a data model that match that kind of need. So for all that kind of things, we're actually using other technologies, and we're only like keeping 50 days of data because after that it's get too big. So we've got Hadoop, we've got Druid for the real-time reporting, interactive reporting, and then we've got other technology that are used internally for building reports for BI and sales.
This will be the last question.
I'm curious about the cache that you mentioned that you have on top of Druid. Is it per user session, so something like Mondrian Cube, which would just build a cache while the user is interacting with the data? Or is it a kind of a global cache that keeps the last day of data?
Actually, there are two levels of cache within Druid. One on historical nodes, where you will just cache the result for specific segments the node is serving, and one cache on the broker side, so you can cache the result of the query itself if you don't have new data ingested in the same time. It's common cache, so it's you can have local cache or memcache distributed on your broker nodes. If you want a cache on top of this on the client part, it's not part of Druid. You have to use something else. If it answers your question.